Hey guys, welcome back to the Pre-Calculus 20 videos. In this lesson, we're going to be looking at lesson 2.3 from your textbook, which this part is all about the ambiguous case of the sine law. So if we're trying to break down the ambiguous case of the sine law, we can really start by looking at what the word ambiguous means. And the word ambiguous means unclear. So really what we're doing here is looking at the unclear case of the sine law. And we say it's unclear because depending on the measure of your angle and the sides that you're given, you could have a number of different triangles that could be created. So there are three different possibilities. You could have 0 triangles that are created, you could have 1 triangle that's created, or you could have 2 triangles that's created. So to determine if you have 0, 1, or 2 triangles, we first need to, draw a little diagram of the triangle that we could possibly be looking at. So suppose I had a triangle A, B, and C, and it had the corresponding sides A, B, and C. And suppose we knew the following information. So suppose we knew the angle A, the corresponding side A, and then the side B. So we have an angle side-side relationship. And then before we can actually figure out how many triangles are created, we first need to find the height of your triangle. And you're always going to start with the top of your triangle and then draw a straight line going down. So when you think about your height is that perpendicular line going straight up and down. So this actually creates a 90-degree angle with the bottom of that triangle. And because we'll be trying to find the opposite side of a right triangle, we can use our sine ratio for right triangles. So that sine of theta is equal to your opposite over your hypotenuse. So angle A here is theta, H is your opposite, and B is your hypotenuse. Then when you find out what your H value is, then you need to compare your height, side A and side B, and use that information to determine if there's 0, 1, or 2 triangles. One thing that's going to be really important here is that in this lesson, we're going to be looking at just acute angles. So angle A here is going to be acute, so it's less than 90 degrees. There are some different cases if you have an obtuse angle. So today we're strictly looking at just the acute angles. So let's go down to our first case. So in our first case here, if your A value is less than or smaller than your height, then there's no triangles possible. So as you can see in this diagram here, if you were to move this side A anywhere along, your triangle without changing the side B, you would see that it would never ever make contact with the bottom of this triangle. So no triangles are created. Then our second case, if we're moving over to the right, this is when your side A is equal to your height. So if they're equal to, then it's only going to make contact at this point right here on your triangle. So there's only one possible triangle, and it's awesome because it's a right triangle, which means you can use your trigonometric ratios for right triangles to solve. Moving over to your third case, if your side A is greater than your side B, or if your A is equal to your side B, then there's only one triangle created. Then the last case here is when your height is less than your side A, but your side A is less than your side B. So essentially, this side A has to be between B and H. So it's in between those two values. And in that case, you have 2 possible triangles that are created. Your first triangle might be a really small angle up here at the top, or you could have a triangle that is quite wide. So there's 2 different possible types of situations that could happen here. So essentially what's happening is you could swing that leg around, and you'll notice that it makes contact at 2 places here to create 2 triangles. So now that we've had a bit of a recap on how to determine how many triangles can be created, now let's actually practice this using an example. So the example that we're going to look at is actually the second part of your first example. So this is actually 1B from your notes. And so here we're given a bunch of information below, and then what we have to do is determine the number of solutions or the number of triangles that can be found given that information. So here we have triangle DOG, and here we know that your angle D is equal to 39 degrees, your side D is 10, and side G is 25. Now, your first step whenever you're completing an ambiguous case triangle question is to first draw an ambiguous triangle. So this might hurt your brain a little bit, but you're only going to draw a partial triangle. And I'm going to draw it the exact same way every single time. That way, you don't get confused when it comes down to, say actually solving the question. I've noticed a few kids, if they were to draw the triangle upside down or backwards, I notice that they run into a few issues. So if we try and get in the habit of drawing the exact same partial triangle, then hopefully we can reduce the amount of errors when we're doing these calculations. So one thing that's really important here is that we're given the angle. Your angle always goes to the left on the bottom there. So you're going to label that angle D and label it as 39 degrees. Then you're going to take your corresponding side. You have side D, which is 10, and that goes across from your angle. So label that as 10. And then you can label side G as 25, and it's always going to go to the left side of that triangle or the one that's adjacent there. So you always want to see this as angle side side. So now that we've drawn our triangle or ambiguous triangle, now we need to do is determine the height of that triangle. So you always start with the top of your triangle, and you're going to draw a dashed line going down, and that'll represent your height there, and label with an H there. So then what we have to do is we actually have to find your height, and because this creates that right triangle, you can use your sine ratio. So you have sine of theta is equal to your opposite over your hypotenuse. And fill in the information that you know. So in this case, angle theta is actually angle D. So you have the sine of 39 degrees is equal to your opposite. So your opposite here is your height, H, divided by your hypotenuse, which is 25. Then your next step here is you can draw, turn your sine of 39 degrees into a fraction, and then all you have to do is cross multiply because now we have a proportion. So draw your arrows to indicate cross multiplication, and then each of those arrows indicate multiplying. So you're going to start with sine of 39 degrees times 25. And just to write this properly mathematically, and that way we don't get confused, you always draw this, write the number for your side first, then the actual angle. That way you don't think you're taking the sine of 3,925. So just to avoid confusion, you always put the side first, then your angle. Then we're going to do our next multiplication. That's 1 times h, or simply just h. And at that point there, then you can actually put this into your calculator, and then we can just go to 2 decimal points. One thing also, just remember, make sure your calculator is in degrees, because if it's in radians or gradians, you're going to get the wrong answer, and that's going to lead to some frustration. So first, make sure your calculator has a big capital D, or it says DEG. Then you can go ahead and do your calculations. Now, watch out with your calculators. You might need to put your angle in first, or you might be able to put it in exactly as you see it on my screen. Once you've got that in, hopefully what your calculator has spit out here is 15.73. That's equal to your height. If you guys didn't get that, hopefully it was just a calculator error, so double check it. If not, come and see me. You might just have to do with switching your calculator to degrees, or maybe it just needs to be reset. So now our second step here is now we need to compare your side D with the height and your side G. So your side D is equal to 10. Your height is equal to 15.73. And your side G is equal to 25. So step number 1 is let's compare your side D to your height. So according to this, your side D is 10 and your height is 15.73. So your side D is less than 15.73. So then you can go back up to your little cheat sheet up above and figure out which case this is. So here what it says, side A is less than your height. This case we had side D was less than your height. Then there's no triangles possible. That's awesome because that saves us a whole lot of work because then we don't have to solve any triangles. Life is great. So we'll scroll back down and we will say there are 0 triangles possible because side D is less than the height. Now suppose your side D was actually bigger than your height, then you want to go through each of those other cases and just see which of those cases fits your example. Then from there, you might be asked to solve your triangle, in which case you would just use your law of sine to solve. So now that we found out how many triangles are possible, that is it for that example. So thank you guys so much for watching. If you guys have any questions, make sure to come see me in class, or you guys can message me on Remind 101. Thanks for watching.